Good morning, everyone. All right, today we're talking about reflections, which is lesson 9.1. We'll be drawing reflections as well as we will be drawing reflections in the coordinate plane. So we'll be doing two types of reflections here. So the key concept here, reflection in a line. A reflection in a line is a function that maps a point to its image such that, first point here, if the point is on the line, then the image and pre-image are the same point. So here, that's in this example, A lies on this line. Okay, so if A lies on the line, A lies on the line, then A prime is, that means the same point. Clearly lying on line K. Okay, and then next case, a reflection in a line. If the point is not on the line, then the line is the perpendicular bisector of the segment joining the 2 points. So here, in this example, you have point A, and you have point A prime. Okay, the segment adjoining those, the perpendicular bisector is line K. Here, that is the perpendicular bisector of the segment adjoining A and A prime. And so you can see those two examples here. So if the point lies on the line of reflection, then its image is the same point. If it doesn't lie on it, well, then that line of reflection is the perpendicular bisector. So here we would say in both these examples that line K is the line of reflection. Okay. So to reflect a polygon in a line, which is what we're going to be working on today, so to reflect a polygon in a line, reflect each of the polygon's vertices, then connect these vertices to form the reflected image. So let's take a look here at this example. Reflect a figure in a line. Copy the figure in the given line of reflection, then draw the reflected image in this line using a ruler. So if you guys will want to use some sort of straight edge, you can use a piece of paper. Perhaps ask for a ruler from this side there. I have some on the desk there. So we want to reflect this image. So let's first reflect point A. So line K is our line of reflection here. So if we want to reflect point K, we want to take we want to go across the figure. We want to be about the same distance from the line of reflection. Remember, it's the perpendicular bisector line of reflection, perpendicular bisector. So this would be point A prime. Okay, we're just graphing that as accurately as we can. Of course, you guys can use a ruler to make sure that that is exactly the same on both sides of the line of reflection there. To do this with point B, well, we will start here at point B, and we observe how far that is from the line of reflection, and we want to go about that same distance over on the other side, and we would have point B prime over there. Okay, and lastly, we would do that with point C as well. But it's supposed to be perpendicular bisector. Okay, bisects that red line, and it's perpendicular. And lastly, like I said, we want to do this with point C as well. So go about the same distance as accurately as we can from line K. And here would be point C prime. And then we, of course, are connecting these. And now, triangle A prime, B prime, C prime is the reflection across line K. So C prime is the reflection across line K. All right. And so at this point, if you guys want to pause and go ahead and try to reflect PQRS there on the next page across, and you guys can pause and try that on your own notes. Okay. So if you're coming back to us now, we are going to reflect all of these points. So let's start with point P. We want to reflect it across from N. So if we were reflecting point P across N, that's going to take us back over this direction. And right there would be point P prime. Okay, again, we're going the same distance from N on either side there, and so I've tried to do that as accurately as I can here with on the board. Okay, and so we're going to want to do that same thing with Q, right? R and S. So just estimating here how far Q is. And we measure that same distance this direction, and we have point Q prime. We've got P prime, Q prime. Let's go ahead and take care of S from our line of reflection. That part's going to go back this direction. Notice it's just a little bit past prime. And lastly, with point R, and we want to reflect that far, so we're going to count that distance out here. And now we just are connecting all of our prime points here. And as accurately as I can, those weren't very straight lines. Hopefully you guys are doing a little better with your rulers. As accurately as I can, that's the reflection of PQRS, and that's what your guys' figure should have looked like. If you pause there. All right, so in the coordinate plane, using a vertical or horizontal line here, this is going to be pretty accurate. We're going to be able to do this pretty accurately. And let's go ahead and take a look how we would do that. So triangle JKL has vertices 0, 3, -2, -1, and -6, 1. We want to graph triangle JKL and its image in the given line. Okay, so let's go ahead and graph triangle JKL. So at 0, 3 is J. K is at -2, -1. And L is at -6, +1. There it is. And we want to reflect this across x equals -4. So that is the vertical line here at x equals -4. All right, so we're trying to figure out, guys, how far each of these points are. Okay, so I'm going to use blue to do the here. So, well, how far is J from the line x equals -4? Well, it's 1, 2, 3. That's 4 units. So on the other side of x equals -4, we need to go 1, 2, 3, 4 units, and that would be point J prime. We can do the same with L. L is 1, 2 units from the line. So in the other direction, we go 1, 2 units. And that's going to be point L prime. And K is 1, 2 units from x equals -4. So we go 1, 2 units from x equals -4. And there is going to be K prime. So these points, K prime, and L prime, connect to make the reflection. All right. So there's an example in the coordinate plane. The next problem, it wants you guys can go ahead and pause, but as you guys flip your notes over, they want you to reflect the same triangle JKL with those same vertices. They want you to reflect it across the horizontal line y equals 2. So I'll let you guys go ahead and pause and try that, and then we'll go ahead and take a look at that together. Okay. So as you guys are coming back here, again, we're reflecting JKL, triangle JKL. Well, we need to plot JKL. We'll use black again for the pre-image. So J is at 0, 3. K was at -2, -1. and L was at -6, +1, and that is point L. Triangle JKL. We want to reflect it across the line y equals 2. So again, that is the horizontal line we see here. And we want to reflect all of these points across. So I'll use blue again. So, well, how far is J from our line of reflection? Well, it's a single unit away, a single unit above it. So a single unit below, and that's going to be point J prime. Okay, well, that is 1, 2, 3 units from our line of reflection. So above it, we need to go 1, 2, 3 units, and that's going to be point K prime. And we're doing the same thing with L, which is clearly 1 unit below our line of reflection. So now we need to be 1 unit above, and that's going to be point L prime. And so connecting J prime, K prime, L prime. Now we have the reflection across the horizontal line. Okay. So that's what your image should look like, J prime, K prime, L prime. So let's continue. Now we'll be reflecting across the line y is equal to x. We're going to reflect across the line y is equal to x in the coordinate plane. So to reflect a point in the line y equals x, interchange the x and y coordinates. So the point xy becomes yx. Of course, we're changing those values. So interchange the x and y coordinates of each vertex is what we're doing, okay? And you can see that in this example, the point B, -1, 4 became B prime 4, -1. They just switched the x and y values there. And A, -5, 2 became 2, -5, A prime. So that's all we're going to be doing to reflect across y equals x. Again, that line of reflection, it's a bisector. It's a perpendicular bisector even in these problems, you guys can see. Perpendicular, and it is in fact bisector. The segments joining A prime and B prime. So, quadrilateral JKLM has vertices. J is at 2, 2, so we plot that point. That is J. 4, 1 is point K. 3, -3. Yeah, that is point L. And 0, -4 is point M. Okay. So this is the quadrilateral. We are going to want to reflect in the line y is equal to x. So the line y is equal to x again contains these points. Plotting them only to help my accuracy on this graphing. So that is the line y equals x. Still missed it a little bit, but we're trying to. I don't like that. So maybe a slight correction here. I don't do this accurately, and if you guys don't do this accurately, so point J was at 2, 2. It's just not going to turn out to look good. And we want it to look good. There's point J at 2, 2. Let me try to graph this line a little better here. Go left. Looks a little better, a little straighter line there. All right, so we want to reflect this across the line y is equal to x, which is here in green. And let's do our J prime, K prime, L prime, M prime, in red. So J was 2, 2. Okay. If we switch the x and y coordinates, J prime is going to be, well, the x was 2, so now it's 2. Okay. It's still going to be 2, 2. If we interchange them, it's still the point 2, 2. So that point is J prime as well. And again, that is on the line of reflection. So if you guys remember back, if the point is on the line that we're trying to reflect in, of course, its image remains the same point. So that one makes sense here. Now let's look at point K. It was at 4, 1. The K prime point is going to be 1, 4. Just switching the X and Y values. So we go 1, 4, yikes. So 1, 4, that's going to be our point K. That would be K prime. If we want to reflect the point L, which is at 3, negative 3, well, its reflection would be negative 3, comma 3, just switching the X and Y values. So negative 3 up 3, that's going to be point L prime. And point M was at 0, negative 4, so its reflection in prime is going to be negative 4, 0. And that is right here. That's all of the points. You can see that we have reflected across the line y equals x. Okay. Reflection in the coordinate plane, kind of a concept summary here at the bottom of your notes. You know, to reflect in the x-axis, you're just changing the value of the y. To reflect the y-axis, you're changing the sign of the x value. And to reflect across the line y equals x, you're just interchanging the points. So your assignment here, 10 through 14, 18 through 28, go ahead and do the evens. Give them a shot. We'll have an opportunity to talk about this on Tuesday morning as well, but you are expected to give your homework a good shot here. So everybody have a great afternoon. Thank you.